Amiel. I'm a rising junior at SAR High School, and this is my starter project. It's the electronic theremin. And basically, a theremin is an instrument that projects an electromagnetic field around this wire over here. So when your hand gets close to it, it makes a sound. And the closer your hand is, the higher pitch the sound is. So just demonstrate it. There's another mode over here. And this is my next project, the laser light show. So just look inside. And basically what it is a laser diode over here, and it deflects off these mirrors and out on the wall, which I'll demonstrate in a minute. And these motors spin at different speeds depending on how I control them. And as they spin different speeds, the laser deflects off of them, and they make different shapes because they're all at different angles. So I'm just going to demonstrate it. So get the lights. There are two modes. There's manual mode and like musical mode. So manual mode, I directly control the motors with these knobs and geometers. So I move them and the motors spin at different speeds. And then I can make different shapes. And then there's also musical mode. And that was actually a modification. So here's another Arduino I added with a wave shield, which is just an add-on that can play music. So switch the mode thing, turn it on, and then it reacts to the music. So I can play songs like Star Wars right now. And it reacts to the volume, so the louder it is, the faster the motor spin. So I can adjust the volume. It makes different shapes depending on how fast the motors are spinning. So that was my main modification. My biggest problem was trying to figure out which pins are used on this motor shield over here, because on the website it says that it uses all but two of them, and then I had to actually look at the library, which is like packets of code that come with the Arduino, to see which ones I can use, because if you use pins that are already being used and you're forced to share pins, which I was, it can mess up the whole thing. And like, for instance, I had something connected to pin 2, and apparently you're not supposed to have something connected to pin 2, so the whole code wasn't working. And I had to switch it to pin 13 over here. So in the future, I hope to make another code which will actually control the motors by itself without needing manual input, so it can make different shows and shapes and all that without me having to either turn the knobs over here and make the music over here. And here are just some of the basic controls. This switches between modes. So this is manual mode where you turn with these knobs, and this is musical mode, you can adjust different songs. This is it actually just resets the song. So if I have a song playing, I can tap in and reset it. This turns the laser on and off, and then these control the different motors when it's in manual. Any questions?
How did you make the outer casing for your project? Was it difficult to correlate that with your circuitry?
So this was actually ordered, and then I had to laser cut or use a drill and a Dremel to cut different holes out of it. So I can cut a hole over here. This is where the laser comes out. And then this is where the speaker is. This is a microphone that picks up the sound. And then these holes for the different attachments. So it's actually hard to fit all the stuff in here because there are a lot of different pieces that need a lot of room. So the Arduinos are pretty big compared to the case. And they need plugs in them, so you have to make sure there's room for that. I have to stick a breadboard in here. And then there are 3 motors and the laser, and you can't have anything over there because then it will block the laser from hitting the wall. So there has to be an unobstructed view from the mirrors to the outside.
Can you take music from outside sources?
Yeah, so it actually uses an SD card. So if you plug into your computer or something, you can just put files on here, and then you can change the different songs by rotating this knob just to put the geometry. Any other questions?
How do you go about arranging the mirrors for the laser to actually function?
So basically, the only constraint is that it has to eventually come out of this hole over here. So I have the laser first bouncing off this mirror, then that one, and then that one, and finally exiting. And if it has 3 motors, each at 90 degrees to each other, it'll always exit at 90 degrees compared to where the laser is coming from. So if it's going that way, it'll exit that way. And basically, I just had to fiddle around with it until it eventually went out the hole, and no matter where the lasers are pointed.
What do you want to do with the sensor that makes the sound when you get closer to it? And what do you say, Michael?
Oh, the experiment?
Yeah.
Well, it's really an instrument. It was developed in the 1920s by accident. So it was supposed to be the instrument that anyone can play, but it turns out it's apparently the world's hardest instrument. So not exactly, but yeah, just people use it in concerts sometimes. In movies, they use this for sound effects because it's sort of like a wailing noise.
How are you generating the different patterns for the laser? Is it due to the position of the mirrors, or is it the software part?
So the laser, it's always a dot, but since the motors are moving so fast and the laser is constantly moving, it just persistence of vision, because if the laser is spinning around in a circle like that, even though it looks like a dot, to us it looks like a complete circle. And then since the motors are each tilted at different angles, it makes different shapes depending on how fast each one's going.
With the first project, I just wonder, with what's going on now with Israel, with all these missiles going all over Israel, how do they know? Is it has anything to do with something like that they can censor
So,
the...
yeah, this I'm guessing is slightly different. I don't know exactly how the IRO works, but this is just like a proximity sensor based on the amount of electrons in your hand disturbing a magnetic field around this. So I think that works slightly differently, but it's an interesting idea.
Even the siren, if there is, to go to the shelter, that's what I'm saying, even something is shooting over from the other side. That's the question. I wonder how they censor it.
So like big experiments around the border, some of these living
I don't know. I have no idea. It's like it's kept to my head now.
Yeah.
You were able to, I think that the gain, so the volume is inside the box or outside the box?
So the volume, this is actually a potentiometer. It's connected to the wave shield.
Okay.
And this just controls the volume. I have it hooked up to an amp just so it's louder. Because if I don't have that, then I can hear it if I'm making a presentation for an audience. It won't be able to hear it because you have to be somewhere close. But the amp just boosts everything, but I can still control from here.
Inside the box?
Yeah.
Thank you.
What's a potentiometer?
It's a variable resistor. If that helps anyone. But basically, what's a potentiometer? So there are 3 wires going into each potentiometer. One of them is 5 volts, one of them is ground, and then one of them is just an output. So it gets 5 volts from one wire constantly, and then the ground is 0 volts. So as you turn it, it moves closer to either the ground or the 5 volts. And then however close it is, it signals whatever's connected to it through the output wire. So for instance, over here, the red is the 5 volts, the black is the ground, and then the white is the output. So if I have it turned like that, it's all the way at 5 volts. So it transmits 5 volts to the Arduino. If I have it all the way on the other side, it broadcasts 0 volts. And then if I have it somewhere in the middle, it's between 0 and 5. And then it can do stuff based off that information.